Okay, good afternoon. We have EE222. We will continue with our lectures. Yesterday's lecture was more of an introductory lecture, just to talk to you about what the course is about and what we will be looking at and what is my expectations. So basically, the one thing which I did mention, and I mention again now, is that just in case some of you enrolled and just came in today, different types of knowledge require different types of learning methods. If you are trying to learn something which is theoretical in nature, like for example, if you are trying to learn law, social sciences, psychology, biology even to some aspect, economics, geography, all these sorts of subjects require you to do reading. For literature, you need to do reading. You read once, then you read again and you underline or highlight, then you read the third time. If you want to do something practical, let's say welding, you want to learn driving, you want to learn swimming, you want to learn football, table tennis, that is a practical course. You've got to learn by practice. You've got to actually put your body and your hands into whatever you are doing. This is an analytical course. Analytical does not mean memorization. No. The theory needs memorization. Analytical means that you need to know techniques, like mathematics. The only way to do it is by practice. Practice and writing. How do you practice? Through writing. You can't read somebody's working and learn. You've got to actually write. Okay? So I would like you to all, if you were not here yesterday, I would like you to all buy an exercise book, whichever one you want. 100 pages, 200 pages is fine, because you can do some revision there as well, right? Buy some pen and pencil, because we'll be doing a lot of writing and a lot of drawing in this class, right? And so when you come to class, you are at an advantage. So you guys, the students who are actually here, you are at an advantage because you're already doing the first round of writing in the class. Second round of writing, you do it within the week. Third round of writing, you again practice whatever problems we will give you in class. You do it before the short test or around the tutorial time. Then fourth round before the examination, final examination. All right? Okay? Okay. Okay, I'm just getting the Zoom session ready. I don't know, I don't think there's any students online. Anyway, okay, let me switch over to the camera. We'll be flipping back and forth with our camera, and we'll be flipping back and forth, you will notice, with camera as well as the screen. Okay. Okay. A lot of things I will use shorthand. These are not lecture notes. I'm just trying to show you concepts. You still have your proper notes. Excuse me, I will flip back now. So you will always flip back. Okay, where will we find the notes? Well, we'll be updating all of this shortly, right? So right now we are on week 1. You'll find some introductory notes on the Moodle shell. So I expect you to have a read through the notes. And what I'm trying to do over here within the lecture, is I am trying to supplement whatever is already over here. So you will find on the Moodle shell notes which are designated lecture 1 or week 1 notes, week 2 notes, and so forth. So what you're looking at on the screen now, right now, is the week 1 note. Fine. What I'm going to do in the lecture is I will expect you to at least have had a breeze through the notes before you come into the lecture. Not necessarily know, not necessarily that you have to have knowledge of that particular lecture, but these things take time to sink in. So it'll take a week to sink in, right? After you've done your practice, you write one round in the lecture, write again, during the evening or during your personal study session inside the library. Once you practice again, practice via writing, not reading. Practice via writing. Remember that. Okay? This is an analytical course. You can only learn it through writing. You can't go and read this particular working, okay, let's say this working about binary addition, or whatever sort of addition it was. You can't read that working and say, yes, I understand it now. Okay? You've got to practice via writing. Your hand has to be in it. Okay. Actually, when you do writing, there's two things which are happening. Number one, your vision, your eyes is watching you, and your fingers are moving. And there's a third thing which is happening. Your mind is instructing your fingers to write something. So once your mind is instructing and you're looking at whatever you're writing, you will learn. Okay? So that is why I'm emphasizing once again about writing this course. Okay, now, so what I was saying is the notes are there on the internet, on the Moodle shell. You have a look at that. You may want to print it. You may want to write it in your exercise book. That's fine. Whatever you want to do, that's fine, right? But in the lecture, I will give you extra material which is not present here. Okay, so that's the difference. That's why you need to come to the lecture, because we will be doing things which are different. Okay. So let's flip back to the document camera. Okay, so as I mentioned yesterday, all digital systems, whether you have a digital watch, I've got an analog watch, mobile phone, this sound system is digital. You may have an MP3 player, you may have a smartwatch, you may be using even something simple as your television, all right, or radio. If it's digital in nature, the digital communication, the way that particular information is handled in binary form. Binary means in zeros and ones, right? Zeros and ones. Okay? That's how it is handled. Now, in order to cater for that handling, right, we need to understand how that particular zeros and ones are processed. So that's the thing which we're going to learn in this course. How it's okay to say, okay, a 5 volts is a 1 and a 0 volt is a logic 0 and a 5 volt is a 1. Sometimes I'll mention certain things like this. I won't necessarily write everything down. Some things I'll mention, you may want to jot it down. Okay? Right? So it doesn't necessarily mean that logic 0 is 0 volts and logic 1 is 1 volt. Yes, that's the basic. And then, okay, over a piece of wire, you're having 0 volt, 1 volt, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0. Okay? Fine. But how is it that something like your calculator, that's something which we can build in this lecture, in this class, right? A calculator. A calculator, when you say 2 plus 3, the 2 is a decimal number which is converted into digital, right? The 3 is a decimal number which is converted into digital, and those two digital or binary numbers are processed to find the answer. Then the answer is again shown to you in decimal. Okay, so this is what happens. What's today's date? What's yesterday's date?
23rd.
Oh, yesterday was?
22nd.
Okay. So I'm just keeping track of. So this was just an intro. Okay. So today we're on, and we will always try and keep track of our lecture number. So we are on week 1, lecture 2. If there's a public holiday on Friday, then we'll just say week 1, lecture 3, public holiday cancelled, right? Okay, so this is how we check our numbers, all right? We keep our date and we keep our lecture number. So sometimes I might say to you, right, just because this is our first proper lecture, I might say, hey, refer to week 6, lecture 3. So you should know what I'm talking about, all right? You should be able to quickly flip back. Okay, so let's talk about a calculator. And why I'm talking about a calculator is because this is something. Oh, are you able to visualize that? Or maybe the lights, I think. Is that right? Is the vision okay with you guys? All right, okay. Why I talk about a calculator is because in this class we will build enough foundational knowledge to build a calculator. We will be able to build an arithmetic logic unit, right? So when you talk about a computer or we talk about a mobile phone, inside the mobile phone there is a processor. Nowadays, what's a good processor for your mobile phone? Anybody? Snapdragon or something like that, right? Yeah, Snapdragon is a good processor. Snapdragon is actually the name of a particular brand of a processor. Inside the processor, there is one part which handles mathematical functions: addition, subtraction, division, multiplication, all that sort of things. That particular mathematical part, the part which handles the mathematical part, is called the arithmetic logic unit, the ALU, right? In a processor is called the ALU, all right? You can write it down, arithmetic logic unit. Now, how do you get to the arithmetic logic unit? We'll get through it to what we learn. We'll get to it through what we learn in EE222. We'll build the foundation up. We might not be able to build a graphics processor. That's another separate thing. When you look at a computer, there's another part of a mobile phone or something called a graphics processor, right? That's a separate thing. Graphics, but again, graphics is based on ALU, right? A couple of ALUs get together, they can build a graphics processor, and that's what handles your gaming and so forth. So there's some mobile phones which are good for gaming, right? How many of you guys play PUBG? Nobody played PUBG yet? All right. How many of you guys watch porn? Okay. All right. Okay. So that's all graphics. Okay, that's all graphics, right? So the graphics processor handles anything to do with images. Okay, all right. And arithmetic, you build a graphics processor with your ALU, couple of ALUs, not just one, multiple, right? So it works in that particular manner. So we build small little blocks. Those little blocks build something bigger. That something bigger builds something even bigger. That something bigger builds even something bigger, right? So that's how it works. But you've got to start at some point in time. You've got to start somewhere at the bottom of the scale. All right. So in order to do an ALU, so let's say when we talk about a calculator, when we do 3 plus 2, what the calculator does is, what humans do is, we as humans don't need to deal in decimal. We can, in a natural manner, say, okay, 3 plus 2 is equal to 5, right? And what an ALU does, right, that's our human calculation, right? We have our own methods to calculate. What an ALU does, it will convert to binary, 3 in digital, or what we call in binary, and 2 in same thing. Then it will do addition. Then, so it will convert each of those into digital or binary, right? Then it will do addition. Then it will do binary addition, and it will get your answer. Over here, you'll get your answer in binary. After finding your answer in binary, what does it do? It takes your answer in binary and it converts back to decimal. See what's happening over here? Just because calculators or arithmetic logic units don't deal with numbers the way we do. So as far as machines are concerned, humans are a far more advanced machine. We don't need to break things down into really simpler level. We can leap ahead, right? Where we slow down is we have lesser memory, right? And our speed is slower. Machines are faster and you can expand their memory, right? So machines are faster, and there are you can have a large amount. You can expand, keep on expanding. If you run out of 1 terabyte, you can put in another terabyte of memory. So when it comes to memory, we are restrictive in terms of memory, right? We can't expand our memory, even though I think Elon Musk is trying to develop some kind of chip which you plug in over here and then you get extra memory or something along those lines. I'm not sure if he's actually going to go ahead with it, but that's what his team is researching. So this is how an ALU works. Now, in order for us to understand, because remember, we are engineers, we want to build the ALU. So our natural starting position is to understand the number system. Naturally, in order to start, we need to start the number system. Okay. So let's look at number systems. So our topic is now let's look at the first example. I expect you to, when you go back this evening or later on in the week when you have a bit of free time, remember you're in university, you're supposed to study during your free time, okay? You're supposed to study during your free time, and so when you're in your free time, you look at the notes which are on the Moodle shell together with these examples. So you'll see most of the time I jump into examples straight away, all right, to explain some concepts. Okay, so let's consider the number. Let's consider a decimal number with let's say 4,837. Set 4,837. Let's roll back to, I think this is this would be year 5 or year okay. If we want to look at it in terms of what position holder these numbers is, so this is a decimal number 4,837. If you want to look at it or think of it in terms of what position each of those digits hold, so we can say that this is in ones, this is tens. Do you remember we used to do this in high school, primary school or something? This is hundreds, this is thousands. All right, so let's now say put that in digits. That's thousands, that's hundreds, that's tens, that's ones. All right. Now, okay. So remember this this placeholder system. Okay. Now, we call this is our placeholder system. We will use that again. This is a particular concept. This here is a particular concept which is used in all number systems. Now, when we think of decimal, so when we think of the decimal number system, right? What can you tell me about the largest number over here? What is the largest number in each particular category? In the ones section, what is the largest possible number in the ones? 9. The smallest possible number? 0. Right? What about in the hundreds? Smallest possible number? 0. Largest possible number? 9. Right? Okay? Why can't we have a 10 as the largest possible number in the hundreds category? There's no space for it. You have only space for one digit. Right? That was 4 digits over there. So a decimal number system, right, it goes from 0 all the way till 9. Right? Which is basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you count it, how many? We've got 10 digits, 0 to 9. So this is the important point. It's not 1 till 10. It's 0 to 9. So remember when we knocked off yesterday, I said we're going to teach you how to count. Yeah, this is very important. We have to teach you how to count. So when we were in primary school, we learned how to count from 1 till 10. What I'm trying to show you over here is no, it's not 1 to 10. It's counting from 0 to 9. Alright? There's a lot of things you will have to rethink all over again. Alright? It's counting from 0 to 9. Alright. Okay. So therefore, because this is 10 digits, it goes from 0 to 9. When you look at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 10 digits. Because it is 10 digits, we call decimal. We say decimal has base 10. Alright, the base is 10. Okay, the base is 10. Because there are 10 possible digits. What are the 10 possible digits? Goes from 0 to 9. Alright, now let us think of something imaginary. If it was, let's say, base 9, what would be the smallest possible digit? 0. And what would be the largest possible digit? 8. Right? So what is the pattern there? I want to introduce another term to you. The term is, which you need in this class, is intuition. Intuition. Intuition means, right, in order to survive as an engineer, it is not necessary for me to tell you every little thing. Remember, you are engineering students. You're almost on par with medical students, right? And you have passed MA 211 and all this, MA 112 and all the prerequisites to make it over here. Fine. So you are almost on par with medical students. It is not necessary for me as the lecturer to go and show you every little step. Right? There's certain things which you should be able to pick up through intuition. Right? Okay? This is not primary school. We don't hold hands and show you, okay, take the next step, take the next step. We show you these are the steps. Move that way. Okay? Right? If it was a kindergarten, then we hold hands and we make you climb one step by step. Alright, so intuition. Let's talk about intuition. If base 10 was 0 to 9, let's say base 8 would be 0 to 7. So from your intuition, what is the formula for the largest digit in any base? Yeah, base number minus 1. So if it's base 10, yeah, minus 1. Okay? Right? Okay, so if it's base 31, it will be 31 minus 1. So the largest number will be 30. Okay. Alright, so I think you guys got it there. Now, let's talk about base 2. Let's look at an odometer. Look at an odometer. All right, let's look at an odometer. Odometer. What is an odometer? Okay, let's look at an analog odometer. All right, over here. This is a good one. Yeah, this is a good one. No, not that one. Here. That's a good one. Let's look at this image. I don't know if I can zoom in to that image. Here. Radio. That's an odometer. You probably, nowadays all the cars are brand new, so you have digital odometers. In the old days they used to have analog odometers. Now odometers is basically an odometer. All right, an odometer is basically a number, is reals, right? Let me show you the picture of the construction of an odometer. Okay, let's have a look at the odometer. So if you look at the odometer, it's like one wheel, and on that wheel, let's look at this wheel here, the one which says 1, is that wheel going from 0 to 9. The next wheel goes from 0 to 9. The next wheel goes from 0 to 9. And then it continues until whatever limit you want, right? In this case, there are 4 wheels, right? The way it works is it works from the smallest number, right? The smallest number is called the least significant digit. Smallest number. The largest number, this number is 6381, right? Most significant digit, right? The largest number. Least is smallest number, right? Okay. So the way it works is not all the bells, they're all interconnected, but they don't all move together. One will go all the way till 9. Once this guy reaches 9, then what will it do? What change will it affect on the next revolution? This will become, no, what is it? It's 8 already. This will become 9, and what will this become once after 9? It will go back to 0, and this will become 9. Okay, let's go again. Right. Again, this one goes all the way. Remember, the one which moves all the time is the least significant digit. So, if this one moves from 0 all the way till 9 once again, remember we've moved this to 9 already, right? What does this become? After 9, this will become 0. What will this one become? 0 again. And what will this one become? 4. So you see, it's all connected. You can't move the higher level digits in any instant. You only can move it after each of its respective lower level digit has done a full revolution, right? You can only move the next digit if the higher level digit, if the current level digit has done a full revolution. A full revolution means going from 0 to 9 and then back to 0 again, right? Remember, that's the catch over here. It goes to 9 and then back to 0. It goes to 9 and then back to 0. So one full revolution will cause how much movement in the next door one? If let's say 3 has one, or 8 has one full revolution, how much movement is there in the next door? Just one, movement by one. All right. So this is simple concept. All right. Now, let us now consider binary. Let us consider binary. Binary numbers. Guys, and if sometimes I make a mistake and I forget to switch over, just call out. Just say, hey, we can't see the screen. Otherwise, if you don't call out, I'll continue writing and then you might miss out on some things, all right? Or if my page is like this and I'm writing over here and you can't see, make sure you call out and say, hey, Imran, I can't see, okay? All right, just call out my name and just say what you want to see, all right? Okay, so let's talk about binary numbers. Remember that all concept of odometer is still valid. Now, in binary numbers, there are only, okay, when we were talking about decimal numbers, how many possible digits? We were going from 0 to 9, so how many possible digits? 10 possible digits, right? Maximum of 10. In binary, there are only 2 possible digits, right? And the possible digits are either 0 or 1, right? A logic 0, now we call this a logic 0, and this is a logic 1. Sometimes they call it a logic low. This one is called a logic high. So, hey, these are different names. Either they call it logic 0 or they call it logic low. They call it logic 1 or they call it logic high. These are alternative names. In the physical world, physically, generally this is 0 volts. This is plus 5 volts. Sometimes they have 0 volts plus 12 volts. Sometimes, so this is 0 12 is generally in some other systems they use 0 to 12. Binary, and sometimes they use minus 3 volts plus 3. So it's not always 0 volts. So depending on the system you're using, right? Okay, depending on the system you're using. Okay, most logic chips they use 0 and 5. Serial USB they use plus 3, minus 3. So depends on what you're using. Okay, all right. So these two, okay. So these are different standards. So if we use a normal logic chip, which you use, it'll be 0 volts for logic low or logic 0 and 5 volts for logic 1. So this is physical world. This is naming convention. So over here, this side here is physical world. And this here, logic 0 and logic 1 is actually for our design, our calculations, our analytics, and so forth. Right? We call it logic 0. For our circuit diagrams and all that, we use these names here. In reality, when you implement on the circuit in hardware, this is what is happening. So some different chips, they use plus 3, minus 3. Some use plus 0, plus 12, right, and so forth. Depends on what you are driving actually. Okay, all right. Now, each of these is called a bit, right? Each of these are bits, right? I think this is very basic indeed. Now, using your odometer, let's use our knowledge of the odometer to generate some binary numbers. All right. Okay. Okay, let's make a table. So we have decimal. Decimal is also known as base 10. Right? Okay, let's just try and draw. Maybe you guys should have a ruler as well, because we'll be doing a lot of drawings. Right? Okay. Let's talk about binary. Oh, by the way, what is binary then? There's only 0 and there's 1. So it will be what base? Base 2 from intuition. Now using intuition now. So binary is base 2. I didn't mention that early on. Alright? Okay. That is base 2. And the other one which is commonly used is octal, which is base 8. Yes, that's right. The other one is hexadecimal, which is base 16. Okay. All right. So decimal, binary, octal. All right. Now let's use our odometer, knowledge of odometer, to go ahead and do this. All right. Now in decimal, the number is 0. Obviously in binary, the number would be 0. Let us say we want to occupy 6 memory spaces. So therefore it will be 6 bits. This is a 6-bit system. This is a 6-bit system, and you will end up with 6 zeros. All right? Okay. Octal. Tell me, in terms of octal, what are the possible digits? Smallest possible digit is 0. What is the largest possible digit in octal? 7. So it goes from 0 to 7. Alright, so your odometer, you have to think of your odometer wheel. It goes from 0 to, the largest digit on that wheel is 7. So after 7, will there be an 8? No, it rolls back to 0. Okay, so octal, smallest digit is 0. Obviously 0 is always easy to play with. Right, now let's do 1. I think it is very easy to do 1. Right, let's do 2. This is where the game starts now. Now, you have an odometer. You have an odometer. Now, the odometer, if it's binary, how many possible digits are there? Only 2, right? So the wheel will have how many numbers? Each wheel. Only 2 numbers. And which numbers are they? 0 and 1. So 0 and 1, 0 and 1, 0 and 1, 0 and 1. Okay, it's done at 0. It turns, it becomes 1. We've already done 1 in line 2 of the table. Right. Then it turns again. It turns again. After 1, what will be the next number? 0. Back to 0. And what will this one become? It was 0. It will become 1. Right? So we have 1 0. Yeah? Okay, we have 1 0. Okay, and this stays the same. This stays the same. 3. Now after 1 0, what can we do? That will become 1 1. Right? Because the last digit, the least significant digit, is the one which moves. Right? This becomes 3. This becomes 3. That's 4. 0 0 0 1 0 0. That becomes. How did we get this? Well, if you have a 1 and 1, this odometer moves. That becomes a 0. Then what does that force this one to become? Also a 0, and this one becomes a 1. You see a pattern now. 4. Okay, what will this become? That's easy because that's only moving 1, right? What will this become? That will move once. The 1 will move and become a 0. This digit here will become a 1. Oh, sorry, I made a mistake. What was the mistake? That becomes 111, right? All right, now here is a tricky one. We have 111. The odometer moves here. This one on the next revolution becomes 0. What will that become then? It will force this one to become 0. This one becomes 0 as well. Then this one becomes 1. right? Let's check this one out. 1011. 1011. So this 1 on the next revolution will become a 1. That will become, this 1 will become a 0. That will force this to become a 0. That will force this 0 to become a 1. Will this 1 be affected? No. So our final digit is 1100. Okay? Tell me, what's the next digit in this case? Anyone? Anybody to volunteer? Just put your hand up. It's okay to have the wrong answer. What do you get? Yes. We have 1 followed by 4 zeros. Now have a look at the pattern. I want you to see the pattern, right? Okay, let's do the octal side. Before we continue, and I would like you to do this particular table. I would like you as homework, as part of your homework. So homework means just being your study session. I'm not going to check your homework, but it's basically I want you to do some practice exercises. All right? Okay. You have to complete the table. Number 1, complete the table from 0 to largest number for an 8-bit system. What do I mean here? What do I mean when I say from 0 in binary, no matter how many bit system you have, will all be just plain zeros, right? To 8-bit system, which means I would like to see 1, 2, 3, 4, 5, 6, 7, 8. 7, 8 binary. When we say bit, it refers to binary. Okay? 8-bit system. Number 2, fill all columns for the same table as in 1. All right. Okay, let's now before we finish off this afternoon, let's now see if you have an odometer using octal. If you have an odometer using octal, what does that mean? Odometer using octal. That means your odometer will go from 0 to 7, because octal is base 8. So after 7, what is the number? 7 will rotate back to 0, and what will this become? 1, 0, right? So you have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, and what do you have after 1, 7, guys? 2, 0, right? Okay, guys, I want to share with you that when we say octal, when we say binary, we put a little 2 over here, a little baby 2 over here as subscript, okay, to indicate that that's binary, base 2. And when we do octal, we put a little baby 8 over here in subscript to indicate octal. Let's now deal with hexadecimal. Hexadecimal, what is hexadecimal? What base is it? I've just mentioned it. Base 16. In our table it shows it's base 16. Hex means 16, alright? Okay? Just like when we used to study shapes, like quadrilateral is 4-sided, pentagon is 5-sided, hexagon is 6-sided, I've forgotten what 7-sided was. 8-sided was octagon, that's why we got the oct or octopus for. 9 is nanogon, 10 is decimal, right? Okay, so anyway, 4, 5, 6, 7, 8, 9. Now in this case, how do we describe 10? What is the notation used? The notation used for the number 10 is A, B, C, D, E, F. Okay, so that's the standard 16 digits. These are the 16 digits. So it goes from 0 to F. F, if you convert it to base 10 or decimal, becomes the number 15. Right? 0 is 0. Right? And sometimes what people do is they say the little 16 over here, some people put a small h. Okay? So you can use two different types of notation. Now, I'm interested to know what happens after F. What? Alright? A0, one answer? Sorry? What happens after F? F all, okay? It's 1 0. Okay? 1 0. Okay, 1 0. Why? Because the F in the odometer, it turns its wheels, right? And then it becomes 1. Okay? That's how you do it. So basically your homework for today, and try and do this tonight, I want you to learn. So when you go and learn mathematics in class 1, or I think it's even in kindergarten, what are the first things you do? Yeah. Book up. All right. Okay. Here we go. All right. Okay. So one of the first things which we do in mathematics, in kindergarten or even before kindergarten, we call it preschool. One of the first things which we do is we learn how to count. So you have learned how to count in decimal. The problem is we don't deal with decimal anymore, right? We don't deal with decimal anymore. I mean, we deal with binary, we deal with hex. These are the two important ones, binary and hex. Okay? We don't deal with plain decimal anymore, right? So you've got to memorize. So we've got to memorize. I'm going to write this down. Memorize this table. I'm usually the type of person which discourages. I discourage people from memorizing. But in this case, what happened to our screen?